All right, now, if you were a person in triangles and in vectors that hated bearing, I have good news for you. We're no longer using bearing anymore. We're looking back to measuring an angle using the unit circle measure, right? The standard measure of an angle. So again, we're going back to like 0 degrees, positive x-axis, moving counterclockwise around to measure a positive angle. All right, we're gonna forget about bearing. We're not gonna forget about bearing. Still need to know it for the final exam, but we're not gonna use bearing in this unit, right? Okay, so let's actually work through some examples. Let's graph some points and polar and go from there. Okay, so here's the deal. Polar graph paper looks like this. We're given like a bunch of circles, right, that radiate out from the pole. And when we go to plot a polar ordered pair, we're going to take a look at the angle and then the distance away from the pole that is. We're going to count the value of r using all of those circles on our polar graph paper. So here's the deal. I have posted like a blank polar graph paper template on the class website that you guys can actually just print out and use for your homework if you like. So if you'd rather not have to like hand draw the graphs, you can just print the polar graph paper and go from there. Okay, so it's there on the class website for you guys. All right, that pole is the center, 0, 0, right? What we know to be the origin. And then we will take a look at the angles and the values of r as we go to graph these things. Okay, so let's take a look at the first set of examples here. In your note packet on page 2, we want to match each of the polar ordered pairs with the corresponding point on the graph. Okay, so let's take a look. First example here, we have the point 3, 5 pi over 3. Now, when we're working with polar ordered pairs, I tend to look up the angle first and then count out the radius. I think it's easier once you find the radius, or the angle, excuse me. So let's take a look at the angle 5 pi over 3. We're going to find that on this graph. Then once I've got it, I'll mark it so that I don't have to go back and think about it again. So look at your unit circle or think about where 5 pi over 3 is. 5 pi over 3 is in the 4th quadrant, or what we would know to be the 4th quadrant, right? And the spoke that's going to represent 5 pi over 3 here is going to be that spoke down there. And just kind of as a side note, that would make this spoke the 11 pi over 6. And I'm just going to jot some of that stuff down so that as I go through and finish the rest of these problems, I don't have to like think about it as much anymore. All right, the spoke right in between them is that 7 pi over 4 then, for using the unit circle. Okay, but we're looking at the angle 5 pi over 3. So we're looking at the spoke that goes out to 5 pi over 3. I will highlight it. And we're looking for a point sitting on that angle that is 5 units away from the pole. And so each unit is going to be one of those circles. So 1, 2, 3. That is point G. G sits on our angle 5 pi over 3, and it is 3 units away from the pole. All right.
So is polar angle the opposite of like your unit circle angle?
No.
Oh, no. Whoops.
Same one. Same exact one. It's like I'm putting the unit circle over all of this. All right, how about 3 pi over 4 then? Well, 3 pi over 4 sits right in the middle of the 2nd quadrant. This spoke up here is the 3 pi over 4 spoke. Now there's 2 points that are sitting on that angle, right? A and B. So we've got to figure out which one has a radius of 5, right? Which one is the distance of 5 away from the pole? Well, 1, 2, 3, 4, 5 away from the pole gets us to point A, for example, number 2. All right, again, if you've got a question, just unmute yourself, shout it out so we can hear it. I'm not looking at the chat right now. Okay, 0, 0, that point, right? Origin or the pole. There's only one point sitting on 0, 0, that's D.
I have a question.
Yep.
Does the second 0 matter?
What?
Like, does the wouldn't the point be the same if it's like any?
Yeah. So we're gonna get there in number 5. But yes, good point. Right? If the radius is 0, it doesn't matter what the angle is. Because if we're 0 units away from the pole and at 7 pi over 4, like the example number 5, I'll just skip down there, we're still sitting on the pole. We're still a point D. So as long as the radius is 0, it doesn't even matter what the angle is. We're always going to be at the origin, right, or at the pole here. Okay, number 4 is a little bit more complicated. So I'm going to put a star next to this one because this is going to be something. This is like one big point today that I hope you guys walk away with. And if you don't, stick around so we can clarify. When we have values of r that are negative, they get a little bit complicated. So remember that r represents the distance from the center, the distance from the pole. But generally, we don't express distance with negative values. Right? Generally, we express distance with positive values. So when we are graphing a negative value of r, we have to do something kind of tricky. So for example, 4, we're going to go to 5 pi over 6. All right, 5 pi over 6, that's this angle up here. It's in the second quadrant. It's the spoke right after 3 pi over 4. Okay, so if we go to that angle on this polar graph, there is a problem because there's actually no point on that spoke. There's no point on that angle 5 pi over 6. And the reason is because this point has a negative value of r. So when we're graphing negative values of r, what we're going to do is we actually go 180 degrees around the circle, or we go across the origin. That's going to get us to this angle over here. It's going to get us to 11 pi over 6. It is opposite the origin of 5 pi over 6. And now we're going to look for a point that has a distance of 4 units away from the pole. 1, 2, 3, 4. So H is actually our answer here. Okay, when we graph negative values of r, we always go 180 degrees around the circle from the angle that we're given in order to plot that point. The reason is we can express polar ordered pairs in many, many different ways. And so this is the way that we work with those negative values so we don't end up duplicating the same Cartesian point with another Cartesian point that's different. Okay, one more I'll do with you guys. Number 6, pi over 2, that's our favorite angle. That's one of mine because it's the easiest to find. Positive y-axis. And what point is sitting 1.5 units away from the origin on the positive y-axis? Well, that's F. Okay, take a minute, do 7 through 12, and then we will go through the solutions there. Maybe you have a virus or something. Ron, do you have a question, or was that from your previous question?
It was from the previous question.
Okay, cool. Sure. All right, if you are, that's a good question. If you're done with this part, the next part is just you guys hand graphing the points, so you can get started on that because I'll just put the answers up in a little bit. Okay. I have the solutions up on the board. Guess I could have gone through them one by one, but 7. All right, this one's tricky. Like only because there's a decimal value for radians, but think about it. All right, 3.3, that's the angle measure. 3.3 radians. Well, we know pi is 3.14, which means 3.3, that's going to be a little bit past pi or a little bit past the negative x-axis. So there's only one point that kind of sits there, which is C, right? And C ends up being also 2.5 units away from the pole. So anytime we're given a radian value with decimals, just kind of compare it to what we know on the unit circle, pi or pi over 2, and just kind of figure out the general area and then pick the point that's there. G, 2 pi over 3, but then it's a negative value of r, so we actually have to go across the origin to actually correctly graph it. All right, so we go down to the angle 5 pi over 3, and the point that sits 3 units away from that on 5 pi over 3 is the point G. Number 9 is very similar to 7, 1 radian, right? Now pi over 2, let me do that in my calculator. Pi over 2 is 1.57. So 1 radian is going to be less than pi over 2. We're going to be in the first quadrant there. There's only one point sits in the first quadrant, and that point is also 1 unit away from the origin or the pole. That's point E. All right, number 10 is B, 11 is F, and 12 is I. All right, questions on that? Any of it? Negative R's? I think the negative R is hopefully as complicated as it gets today. So if you guys can walk away today understanding that, you should be good to go. Okay, I'm going to give you guys a solid amount of time to work through the next set of examples. You guys are just plotting these points, and then I will put the answers up, and then we'll move on. All right, so let me give you guys like 3 minutes to graph them, and then we'll go through the solutions. Okay, people on the Zoom, when you guys are done, can you just raise your hand on Zoom so I know who's done and who's ready to move on? You, great. All right, how about 1 more minute to finish this up? There's a lot of points there, but we do have other stuff we've got to get through, and then I can always come back to this too at the end. Thank you, everybody who's raised their hand. It can, okay. Calculator, just use a scientific calculator, Asher. Okay, 13 through 24, looks like that. I would just go like quadrant by quadrant. A good check is just to make sure you've got the right points in the right quadrants, and that kind of like gets you started there. Any like outstanding questions? People in class, people on Zoom, how we doing? It's just like kind of a different way of shifting your mathematical thinking. Yeah. Like I said, love-hate relationship with polar. I'm learning to love polar. Don't know if I'm there yet. Oh yeah, E's just kind of floating there. It's fine. It's like a decimal. Sorry. Okay. No questions. We're going to move on. If you need me to come back to this at the end of the lecture, I will be happy to do that. Let's get to example C though, which is at the very bottom of page 2. This is where we're going to start really working with these points here. So there are many, many different ways, not many, but there are different ways that we can represent the same point in polar. And so this is practice for that. So we've got some examples here, and what we want to do is we want to take the points we're given and rewrite them first with a radius that is positive, so radius greater than 0, but with an angle that's negative. And then the second way we're going to rewrite the ordered pair is with a radius that is negative and an angle that is positive. So what I'm going to do, and I really apologize, I don't know what happened to the numbering on this set of notes. So we're going to do 13 again. I'm going to sketch the point for 13, and then we'll start working with it. So the point, 4/11 pi over 6. Okay, 4/11 pi over 6 is going to be, I don't know, maybe right there. Where this angle is the 11 pi over 6, and we're sitting 4 units away from the radius, or sorry, 4 units away from the pole, right, or the origin. So let me mark that kind of like that. And now I want to rewrite this point with first a positive value of r, but with a negative angle. So positive value of r, the value is going to stay the same, right? Absolute value of it will stay the same at least. So 4, we're not going to change the distance away from the pole because that would really change the point. But I need to find a way to express this angle as a negative angle instead. So we do that just by going from the positive x-axis clockwise instead. So I need that angle there. If the whole angle is 11 pi over 6, then that's just a small pi over 6, but it's negative. Okay. I'm going to try and color code this. Keep it nice there. All right, now we need also a radius that is negative. So -4 is going to be our value of r for the second part. But we need an angle that's positive. So we want the point in part B to be exactly the same point on our graph as the original point for 11 pi over 6. So to find the angle with a negative value of r, remember we have to go across the origin to get our new angle. So what is across 11 pi over 6? Well, that's 5 pi over 6. All right. Questions before I move on to 16? Because we skipped 14 and 15. Yeah. You have to graph. Directions on your homework. You can submit the homework without the graphs. You're just not going to get all the points there. Up to you. Okay, how about the point 16? Well, 2 negative 5 pi over 4. So it's still a positive value of r, which means we're not going to like move across the origin. We can graph negative angles. It's totally fine. Negative 5 pi over 4 is going to be up in the second quadrant. And we measure it that way, right? Negative angles go clockwise. And we are at distance of 2 away from the pole. So that's my sketch of this point here. Now, in the first piece, we want a positive value of r, but a negative angle. Well, we were already given that piece of information, so there's nothing more to do for A. But for B, we want a negative value of r and a positive angle. So negative value of r is just going to be -2. I just need to figure out what the angle is going to be now. So we're going to go across the origin, right, on our diagram. What sits across that angle? That's what we are looking for here. That's 7 pi over 4. All right, that gets us to exactly the same place on the graph. All right, let's do one more, and then I'll have you guys do 22. So 18. Again, super weird numbering there. 4.83 pi over 2. Love 3 pi over 2. It sits on one of the axes. And it has a distance of 4.8 away from the origin, or the pole. All right, first way we need to express this with a positive value of r. So we're just going to keep 4.8 the same. But we need a negative angle. So our negative angle, again, measured from the positive x-axis going clockwise, that's just negative pi over 2. And then the second option is a negative value of r with a positive angle. So negative values of r mean we're going to travel across the origin, across the pole. We're looking at pi over 2 now. Okay, give 22 a try before I put the answer up. You do not need to do B because we already have a negative value of r and a positive theta. Just find the positive value of r and the negative theta. Can you, I'm sorry, Cheryl. Okay, so let me graph 22 here. Right, this is the point pi over 4. Well, pi over 4 sits out here. And it's right in the middle of the first quadrant, so it kind of sketched a little funny. But we are graphing a negative value of r, so we actually need to go across the origin down here to 5 pi over 4, and that is where we actually graph j, right? And that has a distance of 5.25 away from the pole there. So as of positive r, and as a positive theta, no, negative theta, right? Negative theta, how do we get that angle, right? That's just negative 3 pi over 4. Okay. Questions on that? Thank you, Asher.
Why would it be negative 3 pi 4? We're looking for the dash line that you drew, right?
Yes.
Why would it be negative 3 pi over 4 and not just negative pi over 4?
Okay, so the dash line is in the third quadrant, right? So negative pi over 4, a single negative pi over 4 would be down here in the fourth quadrant.
Oh,
That would be
okay.
negative pi over 4 there. But we want to get all the way to the third quadrant. We want to get to this angle here.
Got it.
So that's the negative 3 pi over 4. Question? You could go, so you could also go counterclockwise, and that would be positive 5 pi over 4. But for part B, for part A, we specify, right, it has to be between negative 2 pi and 0. So we're looking for that negative angle. Yeah. Okay, good questions. Anything else, you guys? Cool. All right, let's keep going. So turn the page over. Actually, you might want to jot some more things down at the very top of page 2 where you've got some space for notes. This is all about converting between Cartesian coordinates and polar coordinates. So we're going between r and theta and x and y. And we can do that using right triangle trig properties. So on the diagram here, I've kind of color coded things. What you see in green is the information that we're given with polar coordinates. And what we see in blue here is the information that we're given with rectangular coordinates. And so it becomes pretty simple to move between the two, as long as we can understand what information is given in what type of system. So in a rectangular coordinate system, when we graph the point x comma y, and then create a right triangle by dropping a perpendicular down to the x-axis, x and y in a Cartesian coordinate system, that gives us the side lengths of this right triangle. When we graph the point r theta, so something in polar, we are given essentially the hypotenuse of the triangle instead, and then the angle in the triangle. So what do we know about the cosine of theta as defined by this diagram? Well, the cosine of theta is just equal to x over r. That's not new, right? This is geometry or trig. But now we can use this to solve for x. So if we're given r and theta, then we can find x by just taking r and multiplying it by the cosine of theta. Then very similarly, we can work with y and sine that way. So the sine of theta is equal to y over r. Then take that equation, multiply both sides by r. Y is equal to r times the sine of theta. It's fun, you can like chuck things along the smartboard. Can't do that on my iPad. Okay, so that's given r and theta, turning it into x and y. How about going backwards though? How about given x and y, how to find r and theta? Well, r is the hypotenuse of this lovely right triangle. We love right triangles here. Use Pythagorean theorem. R squared is equal to x squared plus y squared, or r is equal to the square root of x squared plus y squared. And then very last thing, this one is maybe the most tricky because it might require a little bit more to solve eventually. Theta, we can use tangent in order to solve for theta. So theta is equal to the inverse tangent of y over x. Okay, so last set of examples are just going to work through that information. Let's do it. You'll do the homework like this. Okay. So page 3, number 25 at the top. We have the polar ordered pair. We want to find the rectangular ordered pair. And you guys need to graph. And on your homework, you guys, if you want to just print out the polar graph paper that's on the class website, and then you want to just show all the points, like on the first couple sets of examples, like A and B on the front, as on one graph, that's fine. But these ones just sketch, just like we're going to do for each of these problems individually. Okay, so let's graph it. Pi over 2, positive y-axis, 3 units away from the origin. Looks like that. Right, and that is 3. Now, if you look at the picture, hopefully we could figure out what the rectangular coordinates are relatively quickly. 0, 3. But the math will always work itself out as well. We could also say this is the x value is equal to r times the cosine of theta. Y is equal to r times the sine of theta. Well, the cosine of pi over 2 is 0, so that's where we get 0 for the x value. And then the sine of pi over 2 is 1. If we multiply that by 3, that's where we get the 3. All right, so our ordered pair is 0, 3, and rectangular coordinates. All right, 27, a little bit different here. We've got -2 and 3 pi over 4. So we're going to go to the angle 3 pi over 4. 3 pi over 4 sits out here directly in the middle of the second quadrant, but we're graphing a -2, which means we actually need to go across the origin down to 7 pi over 4. And that is where I'm going to actually plot this point. Okay, and what are we given? Well, I know that that hypotenuse is 2. And I do know the angle inside here. That's pi over 4, right? What we're left with. But the math will work itself out. So the x coordinate is just 2 times the cosine of the angle 7 pi over 4. The y value is 2 times the sine of the angle 7 pi over 4. Cosine of 7 pi over 4 is √2 over 2. Multiply that by 2, you get positive √2. The sine of 7 pi over 4 is negative √2 over 2. Multiply that by 2, you get negative √2. So √2, negative √2 is our point. But there's one thing I'm going to note on this one. I use the positive value of r and then the angle that I got after I graphed this. Right, I use 7 pi over 4. You could have stuck with the original pieces of information. You could have done -2 times the cosine of 3 pi over 4, and then -2 times the sine of 3 pi over 4, and you get the same answers. Right? Question? Great. Okay, perfect. There you go. Vectors? I'll come back to that, Asher. All right, try 29 though, you guys. You're going to need a calculator for that one. Just type it in. Also, you're in degrees, so please make sure your calculator is in degrees here. Graph it, find the ordered pair. Say that again. Okay, so I need the interior angle here is pi over 4 because this whole angle is 7 pi over 4. So what's left? That whole thing is 7 pi over 4, so it's just pi over 4 left. Didn't really need to know that, I just marked it on the graph. All right, now's a good time. If you got a question, you can put it in the chat or you can unmute yourself. All right, there we go. Point sits in the second quadrant, pretty close to the negative x-axis. Our cosine theta is negative 1.25, and our sine theta is 0.81. Questions on that? You guys, as we're going through these examples, I highly, highly recommend that you follow along in your calculator. A lot of people on the triangles test, which are graded, did all of the work correctly, wrote the law of cosines correctly, and then typed something into the calculator incorrectly, and their answers are wrong, right? So the best thing you can do for yourself is follow along on your calculators, make sure everything looks good. And if there's problems, we can troubleshoot those before the test so you don't lose the points on the test. Okay, let's go to the last couple for this set of examples, and then we've got one more. So I'm going to do 26 with you guys, negative 2, 0. So we're still looking at a point in polar, so 0 degrees, okay? But we're graphing a radius of negative 2, so 0 degrees along the positive x-axis, but we actually need to go to the other side to graph a positive 2 value of r. Okay, so this point is 2 units away from the pole, and hopefully this becomes kind of like one of the first ones we did on the last page. That's just a point negative 2, 0 in rectangular coordinates, right? So the point that is 2 units away from the origin, sitting on the negative x-axis, is just negative 2, 0. But again, right, the math will work itself out. Negative 2 times the cosine of 0, negative 2 times the sine of 0, well, the cosine, not theta, 0. The cosine of 0 is 1. Multiply that by negative 2, you get negative 2. Sine of 0 is 0. Multiply that by anything, you get 0. Right. Okay, 28, 30 are yours to do. Really quickly, we'll do the last set of examples, then you guys will get to work. Oh, and then I'm going to show you what we're actually going to do with polar. That's fun. Number 30, definitely need a calculator on that one. Or you could use the sine and cosine tables like my dad had to do in college, sure. Let me just pull the slide rule out for you, Asher. Here you go. Oh, I got one for you. It is sanitized, but I'm not letting you touch it. Alrighty, number 28, negative 5, negative 90. Looks like that. Right, negative 90, negative y-axis, and then you're graphing the negative value of r, so you got to go across it to pi over 2, or positive 90, sorry, we're in degrees here. That's the 0.05. Okay, 30 is plot the point and then plug everything into a calculator. I think that's going to be the easiest way to go for that one. That is going to look like, hold on, delete. There you go. 1.31 and negative 2.36. So number 30 is in radians. Okay, it is 5.22 radians. There's no degree symbol there. So when you calculate that, your calculator needs to be in radians in order to get the correct answers. Okay, questions on that? We got one more set to do. We're going backwards now. So we're going to start with rectangular, find the polar. Lovely. All right. Number 31. We are going to first graph the point and then find the polar coordinates of each point. So the point 3, 4. Well, the point 3, 4. Something like that. Good sketch. All right, but what do I know about the point 3, 4? Well, one side is 3, the other side is 4, and we're looking for the the polar coordinates here. We're looking for r and theta. So I need to figure out, let me do this in a different color, the value of r and the value of theta. Okay, right triangle, it's not even trig at this point, right triangle stuff to find r, right? Pythagorean theorem, r is equal to the square root of 3 squared plus 4 squared. If you guys remember the Pythagorean triples, you don't even have to do the math. This is a 3, 4, 5 triangle. Now, theta gets a little bit trickier. We do have to use right triangle trig for theta. Theta is equal to the inverse tangent of 4 over 3. That is something you're just going to type into your calculator. We are going to stick in radians today because your test will be in radians. I think that's the plan. We'll see. But just do work with radians today.
On the homework, can we do degrees?
Radians, stick with radians. I think I specify on the distance learning calendar if I don't do it the way we're doing it in class. All right, I'll go with 0.93-ish. So the ordered pair then is 5, 0.93. That is the polar ordered pair. Okay, one thing I want to say here before we move on to the next thing. Every single year, lots of points are lost because people swap the r and theta values when they write the ordered pair. So every single year, somebody is going to switch up the order of r and theta, right? And then they'll write the point 0.93, 5. And that is not the same points. So just be careful. Don't lose that point because you wrote it in the wrong order, right? We don't switch x and y. So we're not going to switch r and theta either. Okay, I will do 35 and then you guys will do 33 together. 0, -3. Well, that is, where is that? Down here. Negative y-axis. So it might be a little bit easier, right? So we are 3 units away from the origin or from the pole, and we're sitting on the angle 3 pi over 2. We don't even have to show work for that one. You could if you wanted to. The square root of x squared plus y squared gives you r. Tangent's weird though. You're gonna have to use reasoning for that one. Yeah. Yes. All right. Perfect. I would take that. 3 negative pi over 2. I would also take -3 positive pi over 2. Technically, -3 -3 pi over 2 is also the same point. Asher, you have to list all 4. Everybody else can pick 1. Okay. Do 33, please. Be careful here. You're not going to use your calculator because your calculator is going to give you a decimal and it's actually a unit circle angle. So be very, very careful here. Okay, think about angles on the unit circle And what angles have x and y values that are equal to one another? Right, and that will help us out here for number 33. You could also take a look at the right triangle that's created when you have the sides that are the same. You've got a 45, 45, 90. All right, so 4 root 2 is our hypotenuse of the right triangle. That's our value of r. 5 pi over 4 is the angle because we're in the third quadrant. And we're looking at some pi over 4 angle family. V pi over 4 angle family. Question? Sure. Yeah, that's fine for special right triangles, easy. Not a whole lot of work to show there. Same with number 35. Okay, let's do the last two so we can be done for today. Number 34, we are given the rectangular coordinates 1, negative root 3. So 1, negative root 3 is going to be somewhere down here. I'm going to try and make this a little bit bigger so I don't run out of space. Okay, I draw my perpendicular, and now I know one side length is 1, the other is negative square root of 3. This is a 30, 60, 90 triangle then, right? We've got 1, negative root 3. That leaves me with a hypotenuse of 2. It's all of the ratios of a 30, 60, 90 just multiplied by 2. And our little angle in here then must be 60 degrees because it's opposite the longer side of this triangle, or negative pi over 3 or pi over 3, right? If we're in radians here. Okay, so again, like not necessarily a lot of work to show there if we can reason it out. The distance from the pole, or the value of r, is 2, and our angle is just negative pi over 3. You could have said 2 and then 5 pi over 3 is also an option. That 5 pi over 3 measures counterclockwise. All right, but you could have also used the inverse tangent of root 3 over 1 in order to solve for the interior angle of the triangle and then go from there. Okay, so the math also works that way. All right, very last one, negative 2.667.9 is going to be something like this, right? Up in the second quadrant. That we're just going to use a calculator for. So I'm going to calculate r using Pythagorean theorem. R is equal to the square root of negative 2.66 squared plus 7.9 squared. We don't even really have to worry about the negative on that one. Doesn't matter. Negative 2.66 squared plus 7.9 squared, and then the square root of all that is going to get us 8.34 for the value of r. Okay. Now here's the deal. When I use the inverse tangent, you guys, on this problem, inverse tangent is going to get us this angle in our triangle. That is not the angle that we are going to use in our polar ordered pair, right? The angle that we actually need to use in our polar ordered pair is this angle here. That's theta. But what we can do with our right triangle is find alpha. And then we know that theta is just 180 minus alpha. So alpha is equal to the inverse tangent. And when I use inverse tangent like this, I am just going to take the absolute value of those sides. I'm not going to include that negative 2.66. That will give me a negative angle when I plug that into my calculator. And I just need the absolute value of the angle. I just need to know what the angle inside that triangle is. All right, so in radians, alpha is 1.246. But we are actually solving for theta because we need theta for our ordered pair. Theta is equal to 180 degrees or pi minus alpha. .90. All right. So this ordered pair here is going to be 8.34, comma 1.90. Okay. Here's what I want to show you guys. This is an intro to Polar. All right, that's what we were working through today. Here's ultimately how we're going to use all this information and more closely like what your test is going to look like when we get there. Okay, so we are going to be graphing things that look like this, right? It's like a loop-de-loop sort of a thing. I actually should probably move this into Polar as well, which I can do somehow, but I forgot on. There we go. Okay, another type of graph we're going to be looking at is what we call the polar flower. This one's called the limacon. I can't pronounce it correctly, but there you go. And then that is another type of graph we're going to be looking at. We're going to be hand graphing these things in this unit. And then ultimately what we're going to be doing is we're going to be putting two of these things on the same graph and then solving algebraically for their points of intersection. It goes back to like the solving equations part of the trig unit. We're going to do that in Polar in this unit. All right, so that's what we've got to look forward to. So enjoy the easy stuff for now. Finish up 32, please. I will put the answer on the board. If you've got any questions, now is the time to ask them. Give me 1 second. Let me just take roll before I have you guys leave. All right, I have got roll taken for everybody here now. So if you've got questions, please stick around. I can go back to previous slides if you need to check your work. Otherwise, I will see you guys in office hours this week or at the latest next Monday. Have a great weekend, you guys. See you later.
Thank you.
Bye,
Thank
see ya.
you.
Thank you.
Ross.
Bye, see you
Wednesday.
guys. Have a good one.
See ya Monday.
See ya. Have a good weekend. Yeah, give me 1 second. What's up?
Miss Frank,
Oh, yeah, David,
how
what's
do
up?
we for number 33 for theta, how do we get 5 pi over 4 without any calculations? Like I know it's in the unit circle, but like, I do not know how we got that.
Okay, so negative 4, -4.
Mhm.
That creates a 45, 45, 90 triangle. Right? When the x and y values are the same, this is a 45, 45, 90.
Oh, wait, and then yeah, okay, I got that, but then because that's gonna be 45 and then plus 180. Okay,
Plus
got it.
180, yeah, and then turn it into
Yeah.
radians.
Okay, got it. Thank you.
Cool. What's up? Textbook. I do not have textbooks in this class. So pull your phone out and just look at the link to the digital copy that I have on the distance learning calendar. Alex Brady, how we doing?